Hello everyone. In this video, I'm going to show you how to balance redox reactions using the half reaction method. So you just have to understand that the redox reactions are different in the sense of balancing than normal reactions. And the reason is because there are electrons involved, and therefore, other than the atoms, you have to watch for the charges. And that's why you cannot usually balance them like regular balancing. And that's why you have to follow certain steps to do that. So here I have all the steps that you need to follow in order to do the balancing, but I'm going to show you all these steps in an example. So my example is FeO plus MnO4 minus going to Fe2O3 plus MnO2. So to start the balancing, first thing we have to do is we have to separate the half reactions. What that means is that we have to put Fe on the left, the compound that has Fe in it on the left, with the compound that has Fe in it on the right. And then same thing, we have to separate MnO4 minus and make it go to MnO2. So basically what you have to watch for is that the atom has to be repeated on both sides. So if you have an Fe on the left-hand side, you have to bring something else on the right-hand side that has Fe in it. In this case, oxygen is coming along as well, but what I want to say is don't worry about the oxygen and hydrogen in these cases, because later you will see in steps 3 and 4 that you can balance oxygen and hydrogen later by adding water or H plus, for example. So the main thing that you have to worry about is the Fe, that it exists on both sides, and same thing for Mn. All right. Now, so for steps 2 to 5, that's something that you have to do for each half reaction individually. So what I'm going to do is I'm going to go through steps 2 to 5 for the first half reaction, which is the Fe1, and then I'll do the same thing for the Mn1 as well. So let's start. So it says the first step says balance everything but oxygen and hydrogen. So other than oxygen and hydrogen, on the first one, we have Fe iron. So what we have is we have one iron on the left, but two irons on the right. So because of that, we have to add a coefficient of 2 on the left-hand side. Now the iron is balanced. Then we go to step 3, which says balance oxygen by adding H2O. So now we have 2 oxygens on the left, 3 oxygens on the right. So we're short with 1 oxygen on the left. So because of that, we add 1 water to the left. This way, the amount of oxygens are going to match. Then we have to balance hydrogen by adding H plus. So now we have 2 hydrogens on the left and no hydrogens on the right. So we add 2 H positives on the right-hand side. And then at last, we have to balance charge by adding electrons. So what we have to do is we have to look at the overall charge on both sides of the half reaction. So on the left-hand side, the overall charge is 0 because both molecules are neutral. But on the right-hand side, Fe2O3 is neutral, but we have 2 H positive. So the overall charge is positive 2. And because of that, we have to add 2 electrons to the right-hand side. So keep in mind, always electrons are added to the side which has a more positive charge. Also, another thing to note is all these steps have to be followed in order. So you first have to balance everything but oxygen and hydrogen, then definitely start with oxygen first, then hydrogen, then charge. Because if you don't follow these steps, if you miss the steps or something, like everything is going to be messed up. So that's why it's very important to follow the steps one by one. Because if you, for example, miss adding water, then the hydrogen amount will be different for the next step and everything. So make sure you follow the steps in order that it's written over here. Okay, now we do the same thing. We go through steps 2 to 5 for the second one. So first, as we said, is we have to balance everything but oxygen and hydrogen, which in this case is manganese, which is already 1 and 1 on both sides. So it's good. Then we balance oxygen by adding water. So we have 4 oxygens on the left, 2 on the right. So we add 2 waters to the right. Then next step is balancing hydrogen by adding H plus. So we have 4 hydrogens on the right. So we add 4 H positives to the left. And then step 5 is balancing charge by adding electrons. So we look at the overall charge on both sides. The left side has a positive charge of 3, and that's because we have 4 hydrogens with a +1, which makes it to be +4. And then MnO4 is -1, so the overall charge would be +3. But on the right-hand side, both molecules are neutral, so the overall charge is 0. Because of that, we have to add 3 electrons to the left-hand side. And now this half reaction is balanced too. All right, now we go to steps 6 and 7, which is for the overall reaction. So what we have to do is we have to, for step 6, it says we have to multiply each half reaction by some number so that the electrons can cancel. As you can see, the top equation has 2 electrons on the right. The bottom one has 3 electrons on the left. So the only way I can cancel them is to have a common multiplier of 6, meaning I have to multiply the first one by 3 and multiply the second one by 2. This way, 6 electrons on the left will cancel with 6 electrons on the right, and so the electrons will be all canceled out. And now I can add the 2 equations together. So just keep in mind, when you have a 3 multiplied to the first equation, it's going to be multiplied to every single atom. So it's like a coefficient of every single one, basically. And same thing goes to for the 2 in the to the 2 in the second equation. So 2 is multiplied by everything. And then one other thing to keep in mind is anything on the left-hand side will be added up together. Anything on the right-hand side will be added up together. If you have things on opposite sides, they will get canceled. So based on that, we end up having 3 waters, 6 FeO, 8 H positives, 2 MnO4 minus on the left, and then we get 3 Fe2O3, 6 H positives, 2 MnO2, and 4 waters on the right-hand side. And then we go to step 7, which says that if there's any species like H2O, H plus, or anything else that it's repeated on both sides, you can cancel them. So most of the cases when you're doing these sort of balancings, you will see water or H plus repeating on both sides. So what we have to do is to see how many waters are on each side, and then we cancel them out. So here we have 3 waters on the left, 4 waters on the right. So the net will be 1 water on the right-hand side. And then we do the same thing for H plus. So we have 8 H plus on the left, 6 on the right. So net is 2 H plus on the left. And then we just carry writing over everything else over. So the overall reaction would be this. Now this is all simplified and it's balanced. We call this balancing in an acidic solution. And the reason for that is because we have H plus in the solution as well. All right, so that was it for this video. I hope you enjoyed it. If you liked it, please make sure to subscribe for watching more videos. I'll be posting shortly. Thank you.